Leetcode 238 product of array except self. Given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums of I. Product of any prefix or suffix of the nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in big O of one time without using the division operation. So the first example, if we have nums 1, 2, 3, 4. So if we have 1, 2, 3, 4, and if we are going to write the answer for this one, we should not include this one. Rather, we include 2 into 3 into 4, which is 2 into 3, 6 into 4, 24. So here we got 24. And for the next 2, we will not include this 2. Rather, we include 1 into 3 into 4. 3 into 4, 12 into 1. So here we get 12. And the next case, we'll be having 1 into 2 into 4. That is, we will not be including this 3 because we are processing with this second index. So 1 into 2 into 4. 4 into 2 is 8. So 8. And for the last case, we will not consider this 4. And this will be 3 into 2 into 1, which is 6. So this is what this problem is asking us. That is, we need to exclude the current index number and take the product of all the other index numbers. That's it. So what's the first approach? The first approach, like, consider like we are going to take the whole product. Consider the full product of the given array 1, 2, 3, 4. The first example 1, 2, 3, 4. So what is the full product? It's 1 into 2 into 3 into 4, 24. Okay. So what's our answer? Our answer is 24, 12, 8 and 6. So if we consider this 24, 12, 8 and 6, same as the total product divided by nums of I. So in this case, the total product is 24, and if we are going to consider this first number 1, so 24 by 1, that is 24. So 24 will be the answer at that index. Now for this number, it is 24 by 2, which is equal to 12, and for this number it is 24 by 3, which is 8, and for this number it is 24 by 4, which is 6. So that's the one of the idea that we can apply, that is finding the total product, and for each of the nums of I, we just divide the total product by nums of I, and that will be the resulting array that we are looking for. And the one of the cases that we need to consider is that here there are no zeros. What if there are some zeros like 1, 0, 2? In this case, how you take the full product? Here what we need to do means we need to just count how many zeros are there. If we are only having 1 0, then except that 0 number, all other index values will be 0, because it will include that 0 in their product. Like if we consider here this 1 itself, here we should not include this 1. Rather, the answer will be 0 into 2, which is 0. And if we are considering this 2, here we will be the answer will be 1 into 0. But if we are considering this 0, it is 1 into 2. 1 into 2. So this will be 2, 0, 2, 0. So the first case what we need to do means we need to just find how many number of zeros are there. And if the number of zeros is just 1, then except that position where the 0 resides, all other index values will be 0. And the index where the 0 is, at that place the rest of the product will be the answer, because we will not be considering that 0. The other case is what if there are more zeros. If there is more zeros, then our answer will be 0 every time. So that's one of the cases. But here it's also given a follow-up. What is the follow-up? Can you solve the problem in big O one extra space? Okay. And also without using the division operation. Here we are using the division operation. Here we are just finding the total product. If there are no zeros, if there is 0, we will be considering the total product except that zeros, then just dividing with each of the nums of I. But let's consider with the first follow-up, like without using the division operation. So without using the division operation, here what we need to do means we just need to check for the prefix product. We can create two arrays, one prefix product array and the other suffix product array, and initialize like prefix of 0 as 1 and suffix of length minus 1 as 1. Now just start taking the prefix, that is 1 into 1 1, then 1 into 2 2, then 2 into 3 6, and that time we will be getting 1 1 2 6. So our prefix array is 1 1 2 6. Now the same way we will be doing from right to left. We will be doing from right to left. For prefix we will be doing from left right, and for suffix we will be doing from right to left. And while doing that, we start from the 1, then 1 into 4 4, 4 into 3 is 12, and 12 into 2 is 24. So 24 12 4 1. Now what's our actual answer actually? Our answer is so our answer is 24 12 8 and 6, and our prefix array is 1 1 2 6, and our suffix array is 24 12 4 1. So now what left means we need 24. So see here, 24 into 1 is 24. That's what we needed here. 12 into 1 is 12. That's what we need here. 4 into 2 is 8. That's what the answer. 1 into 6 is 6. That's the answer. So the next idea that can be applied without using the division operation is just keep track of two arrays, one for finding the prefix array and one for finding the suffix array. And after doing that, just take prefix of I and into suffix of I for each of the index I, and that will be the answer that we are looking for. See, 24 12 and 8 and 6. So 1 into 24 is 12, 1 into 12 is 12, 2 into 4 is 8, 6 into 1 is 6. Okay, so we solve without using the division operation, but we make use of, still our time complexity will be big of n, but we are making use of extra space, so our extra space will be big of n. But here another follow-up arises. Can you solve the problem in big of 1 extra space complexity and the output array does not count? So yeah, so that means we can just consider any of this array. Just consider this prefix array, and instead of this suffix array, we can just make use of one pointer, like one variable which starts the value from 1, and just start 1 into 6 6, then update right as right into nums of I, right into nums of I. So 1, then it will be 1 into 4 4. Let's consider here. So yeah, so let's consider the result. Result is just take the prefix as same as we take the prefix array earlier. So same way, 1, then 1 into 1, then it's still 1, then 1 into 2, it's still 2, 2 into 3 6. We done with the left to right traversal. Now just make use of a right variable which is initially set to 1. Now we are going from right to left, so and we will be updating the same result array as the result of I into right, and right is updated as right into nums of I. So after first traversal from right to left, our result will still be 6, and our right will be updated as 4, and this will be now updated as 8, and our right will be updated as 4 into 3, which is 12, and now the result will be updated as 12 into 1, which is 12. Now the right will be updated as 12 into 2, which is 24, and our result will be updated as 24 into 1, which is 24. So 24, 12, 8, 6. Still we get the same answer, and this will hold even though we have any number of zeros or no number of zeros. So that's the idea. The first idea is by using the division operation, finding the total product, finding the count of zeros, then finding the total product, then just dividing with the respective numbers in the index. The next one is making use of two arrays, prefix array and suffix product array, finding the prefix product, finding the suffix product, just taking the product of prefix of I into suffix of I. And as a follow off, to do it in big of 1 space, considering the result array does not count towards the space complexity, we will be just only considering this prefix array, and for this suffix array we are making use of a variable, say right, and it is initialized to 1, then 1 into prefix of I, the right is updated as right into nums of I. So let's try. So if the basic check, if nums is equal to null, nums dot length is equal to less than or equal to 0, is to return new end of an empty array. Let's take the length is equal to nums dot length. Let our result be, our result will be of the same as length of that of the given input array, and let result of 0 equal to 1. Let's start with 1. Now our left to right prefix tracking. So for int I is equal to 1, I less than length, I plus plus, our result of I is equal to result of I minus 1 into nums of I minus 1. So our for the input 1, 2, 3, 4, after this our result will be 1 into 1, 1 into 2, 2 into 3, 6. So this will be our resulting array after left to right traversal. Now we are making use of a variable int right to left, which is equal to 1 initially. This just the instead of making use of a suffix array, we just make use of a variable that is equal to 1 at first. Now doing the right to left traversal and updating result and right to left. So for int I is equal to length minus 1, I greater than or equal to 0, I minus minus, our result of I is equal to result of I into right to left, and right to left is equal to right to left into nums of I. So after this our result was 1, 1, 2, 6, 1, 1, 2, 6, and after this it will be, and right is equal to 1, okay, then 1, 1, 2, again it will become 6, and after that the right becomes 1 into 4, which is 4, then our right becomes 1, 1, 4 into 2, 8, 6, and our right is updated as 4 into 3, which is 12. Now 1, 12, 8, 6, and right is updated as 24, and at last 24, 12, 8, 6. And right is equal to 24. So this will be our final. So just return the result. So here our time complexity is, here we are traversing to the array once, here again we are traversing again, so big of n plus n, which is big of n itself, big of 2n, which is equal to big of n. And space complexity, it's said that our output array does not count as extra space, so the space complexity is big of 1 itself. So let's run the code first. So it's passing now for the second test case where there is a 0, as I told, except this value all other values will be 0, and this value will be minus 1 into 1 into minus 3 into 3, which is 9. So it's passing, and now let's submit. Yes.